All right, thanks. Yeah, so I'm Carsten, working at Bosch, and that's Adam, former summer intern at the Open Robotics. We're going to show you a bit what we did over the summer using ROS2 for vision-based industrial manipulators on robots. And let's kick right in. So at the beginning, there were robots, namely the ABB Yumi or the UF5, which we both were having at, and we had ROS2. Right, and so now if we talk about ROS2, then there are like a bunch of new words floating around, which are pretty cool and awesome, everybody waits for. And we're gonna talk about a few of them in particular. So we're gonna talk about like multimode processors, we talk about the lifecycle nodes, Mikael and Dirk were talking about these already. Intra-process communication, composition, and the amend resource index. And so what we did in the end looks like this. Let's hope that that video plays. So we see like a dual arm manipulator doing dexterous motions with both arms, and we have like controllers written for this using the ABB Yumi driver for now, but like it uses ROS2 for the trajectory controllers and everything. A quick look about the big picture. So like the way it works in writing a controller framework is like you have to have like your robot on the left side here, and then you write something which is called like the robot extraction hardware layer. Basically, it runs your controller loop. You read the joints from the one side using the driver. Then you have like a controller manager, which we're going to talk about in the future. And then the right joints were like, you write that joints back to the robot and make the robot move. Now, this controller manager has then all sorts of controllers with it. It's like here we have like a joint state controller where whenever you call update on that one, it would publish the joint states. Or if you call like the joint trajectory controller, you get external trajectories and then perform them on the robot. If you need more details on this, 2015 ROSCon in Hamburg, Jackie and Adolfo gave like a really nice talk about this. The link is down there, check it out. So now we use ROS2 for this, so we wrote the controller manager from scratch. So one thing we want to do here is like, we want to load these controllers dynamically on runtime ideally, right? So what we want to do is like, can you actually see my mouse here moving as well? Yeah, awesome. So what we actually want to do is like we want to load these controllers by saying, okay, load that package called ROS controllers, and load that class ROS controllers like the joint trajectory controller, and call that node like a joint trajectory controller / left in the namespace of left arm. Then we do the same thing for the right arm, and so we load these nodes twice. Now, how does a potential implementation of this function look like? The way we implemented this right now, so we get our package name and the class name, and we fetch the library path from the amend resource index, and we're going to talk about this on the next slide. Then we use classic class loader, load the instance of a node, load it under the umbrella of a controller interface. We're going to talk about this in the next slide as well. But then, and that's a new feature in ROS2 here now, we call it like, we add the node to the executor and we call spin on it. And so the nice thing about this right now here is that we can easily have multiple nodes, put them in the executor, call spin eventually on it, and we have multiple nodes in one process, which is pretty amazing. And it helps a lot for these sorts of control applications. One quick thing, another new feature of ROS2 is also the amend resource index. So what was there in ROS1 with the ROS pack is like now the amend resource index, and what it is basically like a file system database, if you want to call it like that. I mean, so the way it works now, if you look into your ROS2 workspace install folder, you have a share folder, amend resource index, and then eventually a key for your database called packages. For example, every package which is there in your ROS2 workspace now is registered under that key packages with a file accordingly to the package, in this case like the controller manager. And that's pretty cool, so our tools can now easily fetch all available packages, but just asking in that folder specifically, hey, give me all files which are in there, namely all packages. But the really nice thing about this is now we can also use this for our own individual purposes, namely exporting controllers. So every package which now has a controller wants to export this so that we can dynamically load it afterwards, we just put it in that thing. And by convention, I, out of nothing, just chose this convention. Okay, under this key of controllers now we have a file called ROS controllers, which is our package which contains the controllers to be exported. And if we look into this file, then we see actually, okay, we have the class name followed like semicolon, and then the library path which library contains actually that class. And as like a little wink, because I noticed in the abstract we wrote about Windows compatibility, so I put a DLL in here so it actually works on Windows. Now we have our controllers loaded on runtime, which is pretty cool, but now let's talk about the controllers in itself. There's this new thing in ROS2 also, which is called lifecycle nodes. And what it actually means now, if you look at our possible controller interface, now they all have a lifecycle with it, which means there's a state machine attached to every node, where we can easily now override the states of it. So we can configure these nodes, we can activate them, stop them, clean up, shut down, everything, which is really nice for controllers applications as well, because you want to have like a deterministic execution of your controllers. And so what ROS2 gives you here in terms of lifecycle is like you have a bunch of callbacks which you then override in your own implementation and configure your nodes as you wish. Quickly look into this. We have a possible controller, my controller, which inherits now from this controller interface, does all the fancy stuff with the onActivate callbacks and the cleanups and stuff. But now, how do we interact with these nodes? And for this, every lifecycle node gives you a bunch of services which are attached to it. And so namely, if you now call ROS2 service list, you will see, okay, my controller node has now a service change state, get all available states, and the latest then is like get state, where we can get the current state of it. And what that means now, if we call that service, we get the response, okay, my controller node is now by default in an unconfigured state, so you have to call configure or activate or whatever to get that node running. And so in reality, the way we look, or like the way we implemented this now on the ABB, works like that. So our controller is now configured, both arms are starting, going up and down as a trajectory, and the moment we call then deactivate on that one controller node, you will see that the arm stops, which happens right now. So now it's deactivated, the right arm continues going up and down. We call activate again on the left node, and they both go up, the same on the right. And so eventually, if we call deactivate on cleanup, we go back to our initial home position, which is actually pretty cool and makes fun to work with them. So now this is pretty awesome. So our robot moves, we can control it, but like the real fun comes actually now with Adam when he puts a vision in it.
All right, thanks, Karsten. So I was working in parallel at the same time as Karsten and his intern were working on this ROS control side of things. I was working on a pick-and-place pipeline using ROS2. And the motivation for this was to show that ROS2's features are really starting to get in place to the point where we can start to build some fun or cool applications with them. And as with any integration pick-and-play style demo, there's going to be a lot of integration work, like remapping topics sort of thing. There's also going to be some new functionality when there are things that you want to build that aren't quite there yet. So without further ado, let's build a simple pick-and-place demo in ROS2. We're going to start off, as any good pick-and-place pipeline does, with perception. So we use the Astra depth camera because it's available, and you can buy one right now. And we decided to use the driver that we already worked on for the TurtleBot demo. So you saw earlier yesterday, Chris Lallenstedt described the TurtleBot 2 demo running in ROS2 with Cartographer. That used this exact camera, the Orbeck Astra. So we were able to use the same driver and take the point cloud and RGB data and send it directly to our object detector. So the object detector is new. We built it purely in ROS2, and it's a simplified version of the line mod detector. It actually does use line mod under the hood, but it's simpler than the implementation provided that you might find on GitHub today. So line mod, if you're not familiar with it, is a template matching vision algorithm, which means you train on either real or virtual data. We use virtual data in this case. And then when you observe the real world with your camera, you simply match what you've seen before to what you're seeing now, and that gives you your 6-degree of freedom pose. So if you've built vision pipelines before in ROS, you know that like your computer gets really hot, your fan starts spinning up, and that's just the nature of vision pipelines. But part of that is because that as your data is passed from node to node, it has to be serialized and unserialized as it moves over the wire. You can fix this to some extent with nodelets, but that has other issues. So this is really where we can start to apply ROS2 secret sauce, in this case, shared memory for inter-process communication. So this is something, it's not new, it's been presented before. You can see it there, I think it was last ROSCon or possibly even 2 ROSCons ago. But what this allows you to do is, as long as you have nodes running on the same machine, they can actually just share memory instead of reserializing and deserializing the data every single time it's passed from node to node. So what this allows you to do is create a very low overhead vision pipeline because you're not copying that data over and over and over again. And we actually saw that with this, applying interprocess communication over the pipeline allowed our pipeline to run much faster than it would otherwise. So this is the first piece of ROS2 magic that we applied. And then the next thing we're going to do is we get our 6-degree of freedom pose and we'll send it to our robot. So ROS2, of course, it supports multiple languages. The central 2 nodes are programmed in C++. The robot interface uses UR script and is coded in Python. So multiple languages, check. UR5 robot, we can control it, check. All right. Let's add some more ROS2. ROS2 launch files, they're written in Python instead of XML. This was really fun because instead of writing a bunch of XML, worrying about topic remapping and oh, whoops, I forgot the trailing slash at the end of my XML tag. We can just code in Python. It's much more straightforward in my opinion. And this just works. And then the whole demo runs in ROS2. That's all great. If we want to visualize it, unfortunately, we don't have RViz in ROS2 yet. Coming soon to a ROS near you, right? So for now, we can just pass the visualization data across the ROS2 bridge, which has been described yesterday, I believe, and you can visualize it in good old ROS1 RViz. So this is the pipeline, and we'll wrap the whole thing up in a Docker container. I realized I made a little mistake. We don't include the camera and the robot in the Docker container. This next version of Docker, maybe. But this is so it's easier to share, and also if you go look at the GitHub, which we'll share a link at the end, you can see that you can see kind of how you would provision a ROS2 machine with all of these capabilities in Docker. So we thought that was a useful thing to provide as well. And it made testing easy. Okay, so you may have noticed we don't have a gripper yet, right? How are we going to pick things up? We don't have a gripper. Okay, so we realized halfway through the summer, oh shoot, we don't actually have any grippers. So how do you make a pick and place demo without a gripper? Okay, good question. So we came up with the idea of the picky robot. So we present to you our UR5, the picky robot. It does not like the whole, or it likes whole wheat pasta only. So we're just going to take that cup of noodle and just get rid of it. You see the detections on the upper left. They're a little noisy, but we can filter them. And this was, again, this was trained on virtual data, so it's actually pretty decent for being trained on a CAD model that I whipped up pretty quickly. And then there we go. And then we have another view here. This one, we call this the cat version. We can set the preferences. So this will just push everything off the table. And you can see on the left, that's ROS1 RViz running, and then the 3 windows on the right, those are all running directly out of ROS2, opening up those OpenCV windows. One other thing I wanted to mention, because I have time, I think, we are using a new proposed standard for vision messages, so we're actually detecting the objects using the line mod detector. And then we have a standard that we would love for people to expand upon and use for actually defining how objects are passed across the network in ROS. Because when you move from your vision pipeline to your manipulation pipeline, often that's not well defined. Every lab has their own standards for that kind of thing. So we'd like to unify everyone under one common banner, so that's another thing you can look at if you're interested. And we use it in this demo. Okay, so that's the picky robot pick and place demo. And kind of what are the key takeaways of all this? Well, we have all of these cool ROS2 features, right? And we talked about some of them today. And I think a lot of people are wondering, some people are looking forward to ROS2, some people have already said they're using ROS2 or they're targeting ROS2 for their robot next year. I think what we want to say is, like, if these are the features of ROS2 that you're interested in using, it works. So in some sense, a timeline is looking past where we already are, but where we already are has a lot of the features that many people need. And as we saw, I built that new object detector, so as you see these new leaf packages that maybe don't have many dependencies yet, but that you need for your particular application, you can work to move those specific packages to ROS2 as needed. But the core, we think, is already there. So with that, we'd like to thank some people who made this effort possible. First off, I'd like to thank my mentor, Mikhail Argatis, and I think Karsten would like to thank his intern, Calvin Gunn, and Anything else?
Yeah, also like our friends from ABB and ROS Industrial who helped me personally to get up to speed with the ABB UMI interface. So a big shout out to this. And yeah, so finally, thank you all for listening. Code is available there. Our friends from ROS Control were like, yeah, they hosted our code here for the ROS2 control. It's like, it's a proof of concept. Go ahead, check it out. It's there for visibility. As every good software engineer, I did write documentation, not. Yeah, go ahead, be patient with it, but I keep up the documentation soon. So thank you.
Thank you.
Questions? Don't be shy. Well, I'll start. Actually, while we're doing that, Ugo can come on up. Yeah. So what was you guys both are very familiar with ROS1 and ROS2. What was the most painful thing about building this in ROS2, or the most difficult thing?
Yes, that's a good question. So for me, it was just kind of unlearning the things I already learned on ROS1, I think, because I wanted to use some ROS1 paradigms, and it was like, well, you don't actually have to do that anymore. You can use the shared memory. Your launch files are written in Python now, which is really cool, but I was like, I kind of miss my old XML, but I don't know. I think the Python is ultimately better. I don't know if you have anything you want to say.
Well, one of the challenges for me personally was also that, like, so there's like, you wanted to use a feature and then you realized, oh, no, that's not there yet, right? And then, so like, you have to write it yourself, but which is fine. I mean, like, you have to be patient, you write it yourself, but in the end it works, and it was pretty cool.
Oh, sorry. Question maybe for Carsten. Which DDS libraries were you using, and if the operative system was real-time?
I was waiting for that question. We were using eProsima, but it works with both of them. So like it was the default version, which just comes with ROS2. Is it real time? Well, I think with ROS2 we're on a good way to providing real time capable systems, right? So like we have the shared intra-process communication. We have custom memory allocators. You know, it's always like, you have to know what you do in the first place. It's not that like you write code, pull on the switch, and your system is real time. That doesn't happen, right? So if you know what you do, I think ROS2 is on the right track for this.